welcome to my talk. Thanks for coming and thanks for letting me be here in Kiev. I'm really happy to be here again. So this is my second time. So, who am I? My name is Maciek Próchniak. I'm from Warsaw, Poland, and well, my career began with algebraic topology, monads, group cohomology, and Hotdeploy-blessing. I would be eager to talk to you about this, but unfortunately, my pursuit for PhD in algebraic topology, well, it kind of failed. So now I have to deal with all those mundane jobs, like everybody else. So I work for not so big, not so small, very agile software house named Toke. And by the way, I have a few free board games that my company offered for me to give away. So if you have some questions that I will manage to answer, I can give it away. So, but what's the topic of today's talk? Well, I'm sure you came here because there was microservices in the title. Because now microservices is the real hype. It's real hipster to do microservices. I believe that if you put at least 4 or 5 in your of these topics in your abstract, then you will be sure to be chosen for any conference committee. Right, so everybody wants now to be like Netflix, like Guild, use all those Kafka, history, Kubernetes, whatever. And my company is hip, so we also wanted to do this. So, how many of you are doing microservices right now? Wow. Brave people. And how many of you would like to do it? Yeah, this is more or less what I expected, right? That's why we are here. So we also wanted to do this, right? So what's the hip about microservices? It's just the idea is that you split your monolithic application into some small parts that you deploy separately on your favorite container provider, either Docker or AWS or whatever. They are small, they are easy to fix, and so on. So why do you do this? You want to gain these benefits, like they should be easy to understand, as Dan North says, they should fit into your head. They should be easy to change, easy to scale. You can use different technology stacks, all your Node.js's and Haskells and whatever you may want to use. And you should also be able to achieve some resilience, fault tolerance, and so on and so on and so on. So all goodies, and yeah, just take it, right? But the point is that, yeah, the point is that it's so hip that when we're not doing microservices in my company, we're not doing Docker on Mesos, then some of the people say, you suckers, I don't want to work in this project. Go away, go away. If there's no Docker, no histories, I don't want to work on such project. But the reality is, well, sometimes it's a little bit more difficult, and this is what I want to tell you about. Because it's not so easy to start microservices properly. Like, if you read some more sober blogs than all those Netflix guys, for example, Martin Fowler, then he says that there are certain constraints that you have to be this tall to enter the ride. And what are the prerequisites? Well, the most important of them is that the company you're working for should be able to form DevOps teams and to be able to do continuous delivery. Of course, it's easier said than done, but it's kind of natural, right? When you have all those plethora of microservices that you want to deploy each and every day to have small changes, to have resilience, and so on, then you really do on DevOps and continuous delivery. So when we set up on our last project, we thought, well, maybe we should do this. But then we approach our client. We are not, we are not product company. We are agile software house. So our clients is kind of big Polish enterprises, mostly Polish, so sometimes also in other countries. So we approached our client, and he told us that they are starting to do mature IT. And you know what? You know what does it mean? First, release management. 1 or 2 months planning ahead, no hot fixes, no fast deploys, no. And the second thing is we want to separate development from operations. Yeah, so yeah, because at first they had pretty frequent deployments. They have more or less good cooperation between development and operations, but they want to be mature. So they want it this way. And we quickly run into problems like, you know, we want some virtual server. We know that provisioning physical server takes like 2 or 3 months. Okay, we understand. But to provision virtual server, well, like there are 2 people with permissions to create virtual machines on the VMware. One of them is on holiday, and the second one is very busy. So that's for the DevOps, right? Yeah, and there are also many other communication problems. Like, for example, there are 2 teams. We are working in talk. They have different business owners, and we can communicate. We like each other. We work in the same office. But you know what? The business owners don't like each other. So we can reach agreement. How do we want to cooperate? But they have to have some integration point. Yeah, it's best when it's handled by somebody completely else, like integration layer, ESB, or anything like that. So in fact, our project was about provisioning some integration platform, they call it. So what to do then? The fact is that we are struck by something called Conway's law. Probably you've heard about it because you know what are microservices and so on. But the law basically says that organizations that design systems are constrained to produce designs which are copies of communication structures of these organizations. That kind of long sentence, but if you think about it, it makes sense, right? And usually it's on conferences it's told in such a way that, you know, to start microservices you have to change your organization. But what to do if you know, cannot really change the organization, because you are coming as one of the vendors and the enterprise is big, and you won't be able to talk to all these executives because you are not from Accenture or stuff like that. They just won't talk to you because you are, you know, small vendor, and the company policies are made on 3 or 4 levels up. So maybe you just have to give up. Because if you think about it, how systems in such bigger company, bigger enterprise look like, well, it's kind of different starting from the hardware level and ending at the application level. It's kind of different than working for a product company. When one of our clients is a product company, and we just, well, basically hire people for them, and they're doing the development in-house, and they have nice microservices. They're really focused on DevOps and so on. But the point is that, you know, their whole stack is, well, managed from one office, right? They know each other, the teams are collocated, and so on and so on. And in the enterprise, it's kind of different, right? There are different vendors. Some of them come, some of them go. You have to take over the code, and so on and so on. And so if you think about it, it basically makes sense for them to have one common platform governed by their operations. Because if the vendor goes away, then you don't have to care, you know, what Linux distribution his application was using, and so on and so on. You just take the code, which is of course good documented because you require this in requirements, and so on and so on. Well, nevertheless, microservices didn't seem like a viable option at that moment. So what are your choices then? One obvious choice is to find really powerful ally, probably some, you know, CTO, CIO, or whatever, CO. But then it's, as I said, it's not so difficult. It's not so easy. It's not so. It's not always possible for a small company like us. But if you can, then you can transform the whole organization and, be really successful and get voted to all the conferences you'd like to, to go. And there's another viable option, that is change job. And that's actually what my good friend did, and now he's happy. He's delivering, he changed job. He now works for company doing, all those groovy microservices, all those history, and so on, consumer-driven contracts. Yeah. So that's also a viable option. Sometimes maybe it's the best you can do, but yeah, this is the containers are short-lived, right? And this is, you have to rest at them. Hello. And the other, are we there yet? So it doesn't seem to. Okay, so there's a third option that I'll show you later, and that is sit down and think. Let's do it now. Okay? Thinking. What can we do? Please. Okay, so yeah, no, but I will. I can always talk without slides. That's sometimes also a viable option. I can see this. Not really. Maybe I'll plug it out and plug it in. Okay, that should do the trick, hopefully. No, yeah. What? Ah, man, that's until I've seen something. Do you? Come on. I can see something. No, okay. Yeah. Okay, so we sat down and thought a bit. So what can we do? We have to make some plan to save some of the benefits, because in fact, if we are saying it's not about microservices per se, it's about all these benefits. So what can we save and what can we cannot? We'll see in a moment. Because what are microservices? Microservices, if you think about it, is just another way to build modular application, right? There are many ways, like SOA, or yeah, I won't talk about how was it called? Java component architecture. Yeah, that was also a good specification. So there were many attempts to build modular Java applications. Most of them more or less failed. Microservice is kind of another option. But what does it really mean to be modular? Because there are many things that, in my humble opinion, can be kind of modularized. I guess that's not such word, but still. You can have modular development, that means your code is modular. You can have modular, sorry, bad color, modular packaging. That means that your artifacts are small and modular. And then you can have modular deployment. That's basically what these microservices as they are proposed today are about, right? That you deploy small modules. So this is modularity at the code level. Probably you have separate packages. Maybe you even have separate Maven modules. And if you do it right, then your code is still kind of easy to change and easy to grasp. But this level of But at this level, you still don't get many of these benefits, because then you package everything in one big var or something like this, and you put it into your Tomcat, WebLogic, WebSphere, or whatever. But then you have microservices architecture, when you have separate code, separate jars, or Debian packages, or RPMs, or whatever, and you deploy them to separate containers, and everything is modular all along the way. But there's a third possibility. Your code is separated, your artifacts are also separated. In your Nexus, you have your, 20, 30 artifacts for your system, but then you deploy them as kind of, maybe not one, but 2 or 3 parts, so that the operations team, which is somewhere in far remote server room that you don't know, that they are happy. So how to achieve this? Well, you can use Java. Java is already container, and if you are old enough, you remember this bullshit like run write once, run everywhere. Yeah, we remember that more or less. But still, Java brings us some of the benefits of microservices per se, like JVM. You can do polyglot programming, like Java, Scala. It's all there on this conference. And if you are really freak, then you can use Jython, Fresh, let's not forget that we are working for enterprise, so probably they won't do, but still, maybe this. Maybe even Scala. We are really happy when our enterprise client says, okay, you can do Scala. But what about modular Java? We should just wait half a year? 1 year? 2 years? Jigsaw? Java 9? Java 10? Java 11? Hopefully, someone it will be here, but soon. But for now, it's like waiting for Godot. At least for me, because I try to track when the Jigsaw will really fully emerge, and there will be modules as first-class citizens in Java. But so far, I doubt they will ever come. So what's left? Well, there's this thing called OSGI. If somebody is scared, he can leave. I won't take any, offense. So, how many of you have been programming around year 2000? Yeah. That was more or less the year when OSGI was born. So this specification is not so new. There's a good set of standards done by some standards committee, OSGI consortium, and yeah, it's more or less fixed set of standards. OSGI is kind of, I think it currently is only viable way of modularizing Java applications. Part of the specification is static part. What does it mean to be a Java module? How do you compose them? How do you access them and run? And the other part that is really interesting is about services. How these modules communicate with each other. How do they access their services runtime? This is what we are going to talk about. But unfortunately, well, I would say OSGI is not something that is widespread. It has some partially deserved, partially undeserved bad fame. Because if you look at the famous ThoughtWorks technology radar, OSGI is somewhere here for the last few editions. Like, that means don't touch it for them. Why? Because OSGI is immensely complex, doesn't give you any benefits, it's a huge pain to develop, leads to, yeah. There are many problems with it, and I agree, but still, we have a few minutes left, like half an hour, so bear with me and I'll talk to you about all these peculiarities, or at least some of them. But it has several benefits, which I believe that if done right in this jigsaw that our children will hopefully see, then maybe Java modules will be okay. So, how many of you have done some stuff with OSGI? Yeah, some of you did. Anybody using Eclipse? It's built on OSGI, but I think it's not the best example. Yeah, we're talking about. Yeah, it is like, but you know, IntelliJ is better. Right? Come on. No. Yeah, but But still, what's in for OSGI? Well, the static part is this definition of modules, that is bundles. A bundle is essentially a jar with some pieces of metadata. We'll see it in a moment, what's there. It's basically something called exports and imports, and it just says which classes are parts of my public API as a module, as a bundle, and which classes are my private thing and you cannot touch it, and you perform some really heavy class loading voodoo. Because you know all these module structures is well, it's based on class loaders. If you think that Tomcat class loaders hierarchy is complicated or complex, then yeah, maybe you shouldn't look at the OSGI, because there are many interesting things happen. Yeah, and also the bundles define versioning. Here is hell. Yeah, because you know some how it is, right? It's not like you put dependencies in Maven and it just works. So more or less, this is the manifest file if your jar is a bundle. It looks cute, right? Now, fortunately, you don't have to write it by yourself because it's generated by bundle plugin. And one it's here, it's basically definitions which packages of our bundle are exported. That means they can be accessed by other modules. For example, if your package name contains some words like implementation or internal, then Maven plugin thinks, yeah, probably this isn't part of the public API. And also there are your dependencies, the packages and version ranges that you depend on. Right? This is kind of more or less semantic versioning. If you know Maven well enough, you know that you can even in Maven declare that your dependency have version range and not particular version. And there are many more additional headers, but we won't get into the details so that you don't run away. And this is the versioning problem, right? This is taken from I guess also Martin Fowler's blog about versioning REST services, and it's kind of complicated, but more or less depicts the problem when you have a few libraries or services depending on each other, and each depends on kind of different version of this product module. So the point is, if these are REST services, they will probably more or less work, because in HTTP and REST, you probably don't have such full versioning control, unless you are really hardcore Rastafarian, of course. But in OSGI, this won't happen. OSGI will just say, no, I refuse to install that. You have to decide which product version do you want to use, but I refuse to even start. So you get some big stack trace in front of your face, and yeah, you have to do something with it. So that's kind of intimidating. But I think that it's not a problem of OSGI, because versioning is some kind of inherently difficult problem. This is not accidental complexity, it is a real complex problem. So maybe sometimes it's better to know about it from the beginning and know not on some mythical Saturday evening when something burns in production. So OSGI let us define all those bundles, versions, but it has certainly bad fame. Most of the bad fame comes from the fact that many successful, more or less, Java libraries, not to mention Scala, and Groovy and so on, they just ignore OSGI. They can be, as people say, be OSGified, but it's a difficult and complex process, and some of them, like Hibernate, are just notorious and refuse to cooperate. So the problem is that it's, as my friend said, this OSGI is so problematic because I cannot take any fancy library and just throw it into the Maven and it just works. Yeah, the problem is that it is true. In many cases it won't work, but I hope that sooner or later the situation gets better, because if modules for Java are to work, then all those libraries would have to be somewhat prepared for that. Also, the tooling is kind of subpar. it's getting better and better every year. Like 3 or 4 years when we began our OSGI adventures, it was really worse. But still, you have like tools like BND for generating manifest, supporting Eclipse and IntelliJ. There is one, but we usually disable it. Only the Maven plugin works more or less. But yeah, you have to put some work for OSGI to get it working. But somehow I feel that sometimes it's worth it to make your application modular. So it basically looks like this. So you have one service inside our one OSGI container. It's API service. They use some libraries, and if you think about it, it's kind of similar to microservices. So there's service, there's API, which is probably implicit, not explicit, and we're just in different containers. So yeah, start to looking familiar. But even more interesting part of OSGI is kind of, I would say, dynamic part, because it's often forgotten. People usually just tend to think mostly about all those manifests, versioning hell, and imports and exports. And this is really interesting stuff. It really hides many hidden gems, and these standards are kind of, I would say, well thought. It's most of the time when we want to do something, it just works. And they are called microservices with micro. And they have been called that like, I don't know, for 7 or 8 years, I think. So if they are really older, they are really real microservices. And they basically looks like this. So we have a service, and it says, I want to publish this object as some kind of interface. So there's some central registry. This is all one JVM in OSGI containers, and other services can have this service injected. They have to use common API, just normally, but the API is just normal Java interface, and the registry takes care of not also registration, but injecting, informing that the service comes, goes, and kind of maybe not load balancing, but manipulating them to all dependencies to be satisfied. So how does it work? I won't show you the kind of low-level API because it's not intimidating, but it's like 15 years old, so there are no generics, no kind of oldish Java. But there are a few frameworks that enable you to do this stuff, to make services with kind of normal dependency injection. We'll see in a moment. Both of them are standard. One is called Blueprint, the other is called Declarative Services. Has any of you worked with them? Yeah, somebody did. Did you like it? No? Ah, yeah, good. So this is how Blueprint likes. It's just like Sprint 2.x, like 10 years ago. Yeah, this is just Spring. You just know it's Blueprint because it's set here and it has some fancy schemas. But this is more or less old Spring. So and in fact it's poor man's Spring. You cannot do too much here. But if you are developing microservices, then you don't need probably all those Aspect-J, proxy, bin, factory providers. As we've been told last year, I remember the last talk that lasted like an hour and a half, and the guy just talked about different bin factories here in Kiev. That was really interesting. So this is the somewhat simplistic view of dependency injection. What's kind of only thing that's interesting is that we have references. That means that we don't declare the bin, we just declare that we want to access bin named data source, and we want it to have data source interface, and we want the OSGI registry to inject it. And but it's kind of old style. Yeah, that's true. And the other one is kind of like 5 years younger. This is called Declarative Services, and it also looks like Spring, right? You have component, you declare that it will be published as a coffee service, and these are just different annotations. What's interesting is that, well, in fact, these annotations are not used in runtime. These are just used by the Maven plugin to generate some horrible XML to be put into metadata. But that's, well, let's skip this part. So this looks like more or less normal dependency injection. There are a few quirks, but still. But what is interesting is that, you know, when you have Spring application in CDI or whatever, then it's basically static, right? At the beginning of your application life, the beans are parsed, they are constructed, and everything is fixed. But OSGi is fundamentally dynamical. Just like in Eclipse, you can add plugins in runtime, and then you have this gorgeous window saying, "We'll try to install the plugin, but please be prepared to restart." Yeah, that's the OSGi. That's the spirit. So you can do code hot deploys, but you know, sometimes things won't work. But the thing is that this is interesting that you can do this. So the life cycle of such OSGi service is much more complicated, and in fact it can be handled by those frameworks. For example, here's our coffee service bean, and we can annotate methods that should be called when it's activated or modify. That, for example, when you deploy a new version of the service, or for example you change some configuration. And speaking about configuration, OSGi also has pretty nice standards concerning application configuration. It's like, you know, all those fancy Netflix Archios, or how is it called, libraries for managing configuration. And again, OSGi had it for, like, I don't know, probably last 10 years. It's of course based on properties files, no JSON, no XML, no. Oh, it's usually it's file backed, so you have your properties files that are monitored by your OSGi container. But what's interesting is that you can dynamically update your services. And again, in the case of declarative services, you just put your annotations like activate, modified, and then you just insert a parameter like map, and your configuration will be just injected. Here you declare what's the PID, what's the name of the properties file. So each time you change the configuration file, this method will be invoked, and you can react if you like, or you can restart the whole damn thing. So it's kind of interesting that you can dynamically not only hot swap code but also swap configuration. Sometimes it can be really nice, for example, when you want just to, I don't know, to tune the connection pool parameters or change the subject of, I don't know, welcome email, right? Then you don't have to restart the whole damn thing, but you just change. So this is more or less what it looked like. And how would it, well, look like in some kind of, you know, reference microservices implementation? Again, something a bit similar. Probably you'd have like Zookeeper or etcd or something like that. But we still have different containers, but it more or less resembles it. Of course, there are subtle differences. But what if your application starts to getting larger and larger? Somehow you want to, in fact, you want to separate it, to divide it into, I don't know, maybe not 20 services, but like 2 or 3, because you have to have 2 instances of one, 3 instances of another one, and your ops agreed. So the thing is that you can have DOSGI, that is distributed OSGi, and that basically means that, yeah, you do have some Zookeeper registry, these are probably some REST services, but your code remains intact. That's just a matter of configuration of this whole damn containers. They perform the auto discovery, they perform the routing and so on. But your real business code is just the same as it would be in the case where you have one container. This is quite nice because it somehow allows you to defer the moment of division to when you really need it. It's not like with, you know, some microservices nowadays, when you just first you split the code, then you deploy it, and then you think it's really worth it. So first you first develop for one container, and only then you change the thing. Of course, yeah, I remember how it was with, or maybe not really remember, or try not to remember with old AGBs, when you have, you know, you didn't really know on what server they would be invoked. So you know, you have to be careful and take into account all those fallacies of distributed computing. But I think if you design your system well, that it will be okay, hopefully. And if you cannot design system well, then microservices won't save you, right? At least I think so. And now I want to talk about the OSGI containers per se, because there's OSGI frameworks like Felix, Equinox. That's just most low-level part of the OSGI stuff. But then there is Apache Karaf. That is like 4 or 5 years old. I think it's really nice piece of software. It's basically kind of micro container. It weighs I don't know, like 5-6 megabytes, and it contains OSGI frameworks of your choice, either Felix or Equinox, and some additional modules like this. It has shell console, extensive logging support, some pluggable, everything is pluggable in OSGI, of course, pluggable deployment modules so that you can either deploy your code via JMX, next new trendy technology, or you can just put it in a hot deploy folder and then it will be picked up automatically. It has nice provisioning methods when you say what do you really want to deploy in some metadata. Yeah, it says blueprint containers, declarative services, and so on and so forth. So it's a really nice piece of software. I don't have, of course, time for demo, but there are some 2 or 3 screens. This is the console. You can just SSH to inside your container, and you can, you know, list all your packages, do some grep. This is all written in Java. Now, this is kind of nice. You can also, you know, join these containers into some kind of ensemble, and you can, by this very shell, stop them and start them. Sometimes it's kind of nice. But if your operations guys are not into Bash, they can always use some web console. That's actually an interesting project in itself. It comes from Red Hat. It's called Hawtio. I don't know how do you pronounce it. Let's call it Hawtio. And it's basically an extensible web console that allows you to talk with any application that has JMX interface. And it does it by some library called Jolokia that allows to expose JMX interfaces as REST APIs. So this is basically an Angular application that talks via REST to your JMX interfaces. This is, I know it sounds weird, but it's actually pretty cool, because most of the kind of, you know, enterprise libraries expose plethora of different JMX interfaces, or even for looking through logs. So you can have, you know, one console for your whole data centers and connect to it. It's under, well, I would say really active development, so things are changing pretty fast. It's kind of, I don't know, 1-2 years old, but it's a really interesting technology. So this is how you access your container. What else? Well, the rest of my talk is about something I would say more or less like work in progress, kind of, because this is the state that we want to achieve, and we are not there yet, because mostly because we were stuck for some time using some open source Red Hat product, which they abandoned in pursuit of Kubernetes and Docker and whatever. So we left with the code, but hopefully some guys from the Apache Karaf adopted some of the code. So the rest of the things I'll tell you about won't work today, but tomorrow hopefully yes. And I really mean tomorrow, because the appropriate release of Apache Karaf is really on the way, like for a month or 2. Okay. No. It's come on, it's not Oracle. but the problem is that, you know, it depends on like 5 or 6 different libraries, and each of them has to be released. And now we're waiting for Felix to release. And now we're waiting for Jolokia. Oh no, but this library has been released with different and versioning hell continues. So it takes them quite long to release. So the idea is to have some nice metadata that will describe your which bundles, which modules should be installed on which containers, and also which configurations should be there. Because you want to have kind of, you know, simple instructions for operation guys so that they cope. Maybe not so complicated like this, but you know, the Duplo blocks are kind of simpler. So for operation guys, it might be like this. And this is more or less how it looks. This is the metadata. This part is fully working in Apache Karaf. This is thing called features, and it's just grouping different bundles. That means, you know, essentially jars with libraries and services that's grouped together. There's just, you know, a bunch of XML files that tell the container what to install so that you don't have to manually copy everything. And here you say, okay, so take this bundle, and where do I find it? Well, in your configuration files, in your Karaf configuration files, I told you where is our nexus. So you take the Maven, and these are the parameters. So you don't have to deploy the jars manually. You just have to make sure that the container can access nexus. And there's kind of new feature, like it's named profiles. That's kind of hierarchical structure when you can group not only the feature files that describe bundles, but also you can put some different configuration files, some blueprint XMLs, and so on and so on. And all these, this is nice because this is text-based metadata. And where do you put text-based metadata? You put it in the Git. This is actually our production GitLab. Hopefully cropped all necessary things. Yeah, but it's just admin here. So all the metadata is kept in the GitLab, where it can be, you know, normally accessed in normal Git way, either by developers or by designers of I would say containers, who decide where do I put this and where do I put that, and how much I don't know, for example, connections in the pool there should be. So the pipeline, this is kind of, we're still one or two steps before it. The pipeline is more or less like this. You have this Git repository when you put all those configuration files. Then you have Nexus when you normally, you know, deploy all your artifacts that you develop. So this is not the Git for your project. This is the Git for your kind of enterprise when they put their configuration, the metadata, and so on. And then you have some, let's call it Jenkins, when you have just one button that says, yeah, take these metadata from the Git. There are Maven plugins for this, so it will work. Take those metadata, take the stuff from the Nexus, build me a container, and deploy to service this or that. So actually, this is pretty cool. And you know, because it's Git, it can have kind of audit informations for anything. You can say that this Git branch is for test environment because we want to test this configuration, and currently we cannot deploy it on production. So for production, we have this branch. So this is, if you think about it, at least when I thought about it for a week, I thought, okay, maybe it's not so loser way. Maybe it's pretty cool. At least I hope it will be. So all this stuff, OSGI, Karaf, and profiles actually give us quite a few benefits. Like, as I said, they allow us to defer the decision where to put which services, which containers to the last possible moment. Should they be together to perform more, to perform better, or should be split for some reasons like load balancing. So another thing is that they allow us to separate the code from deployment, from the metadata. So we are happily coding. We have our Git repository when we define all those containers for testing, but then come the operation guys, or they are called container designers in our language, that can decide which package should be deployed on production in 1 month. Yeah, so they can build it and deploy when they want. And it's also pretty nice that This is built on standards. That OSGI, you know, it's not widely adopted, but it won't go anywhere. I can assure you in next, like, I don't know, few years. Whereas about all those OSS libraries, sometimes they're okay if they're Apache, but they've learned that if something is on GitHub and it's backed by a single company, then you never know what will happen in a few months, because it may very well happen when, you know, they will abandon it. The code will be unmaintained, and it's kind of tricky. But still, there are some limits, and the biggest limit is about resilience and the easy to change thing, because this is the reason. This is the Java doc from thread class, and it says stop is deprecated, and this method is inherently unsafe. And that's the state from, I think, Java 1.1. So they didn't remove it because they cannot remove anything, but it's really deprecated. And what does it mean? It essentially means that you cannot kill your service without killing the whole JVM, right? This is a really limitation, because if you have some poorly written service that is all your CPU, then you cannot kill this just one module, one bundle. You just can't do it in Java. There's no way. If the code is loops endlessly, then you cannot do anything about it. Whereas in, you know, all those Docker containers, you just kill, like in Unix. So hot deploy, yeah, it's possible, but it's really good in development, because if you try it with Karaf and with Maven, then you discover that it's almost like JRebel. Almost, but you still have kind of good experience, code that you don't have to redeploy all the application to have some code changes. But in deployment, it's kind of inherently unsafe. We had some problems when, okay, we did some like hot swaps for half a year, and everything worked. The server was running continuously, and the client was happy. But when we restarted the server, well, it turned out that it can't start anymore. Because 3 months ago or 4 months ago, we had some bad change that could be hot swapped, but the server wouldn't work anymore. So I think that we still want kind of unmodifiable containers. That if you change it, then you have to, you know, put new version, redeploy it, restart it. I think that usually you want to have some redundancy anyway, so that's not such a big problem. And when we are talking about internal enterprise applications, then usually doing this at the midnight, it's kind of tolerable. So when we look at all those benefits, we can see that we kind of can get some of these benefits. We can separate our code so that it's easy to change, JRebel-like, kind of easy to scale, because we can defer the moment when we divide it and put it into different machines. Of course, we can use different languages provided it's on JVM, and with resilience it's somewhat worse. But if you can cope with it, then it's kind of okay. So the takeaway that I would like you to get from this talk is maybe not to use OSGI, because, you know, this is not for everybody, I would say. But just remember that because you don't have root access to your virtual machines, or you don't have containers, it doesn't mean that you cannot build modular applications. You still can. There are ways to do it. But, you know, everyone has to find his or her own way. Right? Our was probably this one, and yeah, we got to that point. But it's near the top, so hopefully we will make it. And I hope that you'll also make it. Okay, so if everybody has some questions and want this game to go ahead. And if not, we're heading, you know, where. Yeah.
Is it possible to is it possible in OSGI currently to depend on a range of versions?
Yeah. It was even possible on this manifest file that I shown you.
Okay.
So yeah, the range support is pretty okay.
Thanks. Anybody else?
I could answer that one. Come on, I won't take them to Warsaw.
Are there any like more lightweight alternatives for Karaf?
You can always take only the OSGI framework, but then you have to cope with logging, with code deployments, and so on. So you still have to have some few frameworks, few libraries. So I think it's kind of possible, but I don't think it would be necessary, right?
Which enables us to, for example,
what do you mean by microservices framework?
Vertex is a good example, right? Which is kind of a container to which you load modules, and you can unload them, reload them depending on the load of the server. You can change the purpose of the server or the services.
I think it's not so far from what's Karaf doing, because you can deploy modules, and if you are talking about even the bus from Vertex?
A little bit more there is, right?
Yeah, because if you employ this DOSGI, it's actually not so far away, right? I mean...
In the concept, yes. In execution, no.
Yes, in execution, no, but in fact, yeah, but you know, what's the missing piece that Vertex has?
So actually, that's kind of a part of the question. What we're missing? Why we have? Because for Vertex, there's a long discussion right now of doing a new framework, which is actually based on Karaf.
Vertex 3.0? Or something else?
No, completely different. I think new.
Really?
Yeah.
Okay.
I think it will be dead, but who knows? Maybe some good idea pop up from it.
Things happen. I mean, I think it. With I don't know Vertex that much. I know there are some modules and called verticals, and there is this event bus. But are we talking about this dynamically reloading verticals? Yeah, I see what you mean.
Which is pretty cool when you can actually have, for example, 10 instances and just repurpose them.
Yeah, that's interesting. I mean, I don't think anything prevents such deployment. In fact, this abandoned product that I told you about from Red Hat, it was called Fabricate, could do something a bit like that. There was some auto-scaling features that the problem is that they were not fully baked. Right, they tried to do something but they left. But they tried to do it, so yeah, maybe.
Fabricate is not abandoned. So which version of
yeah, I'm talking about Fabric 1. The first version, and because the second version is based around Docker, Kubernetes, and stuff like that.
Yeah.
So it's, I mean, they
almost completely new.
Yeah, they just drop the code base, and okay, you can have containers based on Karaf, but it's completely different philosophy. And our client didn't want such containers, so.
It means that they decided that OSGI structure is not what they want, and There are some better solutions like
I mean,
Actually, I feel that it's more about complexity at the time than structure itself.
you know, these are just my guesses, but I think that they are a part of Red Hat now, right? And they have all those OpenShift, they're into Kubernetes and so on. So I think that this was just kind of, you know, technology alignment so that they can fit.
politics.
Yeah, I mean, you know, I don't know that, but it looks like that for me. Okay. So, if no... Huh?
Sorry, just one.
Okay, if no... We can discuss it still if you want, so... But if not, then